Okay, this is our last section in Chapter 7. And we're going to go back to applications, right? Applications. Okay, you can read over these steps for solving an application if you want. Let's just dig right in though. Okay, a rectangular soccer field has a perimeter of 360 yards. Its length is 20 yards more than its width. What are its dimensions? All right, so I know it's a rectangle, so I'm going to take advantage of that. Okay, its perimeter is 360. I got to know what that means to be the perimeter. That's just if I add up all the way around it, it's 360. The length is, right? It's just telling me the length is 20 yards more than its width. So it's the width plus 20. It doesn't tell me anything about the width, so I'll just use a W. But the length is the width plus 20. So if I add up all the way around here, it's got to equal 360. So W plus 20 plus W plus W plus 20, right? 1, 2, 3, 4 sides. That's got to equal 360. Okay, I've got 4 W's plus 40 has to equal 360. Just solving this equation for W now. 4W has to equal 320. So divide by 4. W is 80. 80 yards. And the length is that plus 20. So the length is 100 yards. Okay, so not too bad, right? That one's not too bad. For the 2013 Major League Baseball and National Football League seasons, based on average ticket prices, 3 baseball tickets and 2 football tickets cost $245.52. 2 baseball tickets and 1 football ticket cost $136.50. What were the average ticket prices for the tickets for the 2 sports? Okay, 3 baseball tickets and 2 football tickets cost equaled $245.52. 2 baseball tickets and 1 football ticket cost equals $136.50. Okay, so notice I just got 2 equations. So I can either use substitution or elimination. I'm going to use elimination and multiply this bottom equation by -2 so my f's get eliminated. Right? -2, -2, -2. So I wind up with that top equation is going to stay the same. And now I'm going to have -4b minus 2f equals negative, let's see what that would be, $273, I believe. What do I have? 52. Okay, gonna double check my math there. So 12, 6, 7, yeah, $273. So those get eliminated. So I have -b equals, let's see, that's going to be 48 cents. And I can go over to this side and subtract those if I need to. right? So what is that then? I'm going to borrow from the, so 7, and then, so $27.48, if I did that right in my head. So go over and subtract them, right? All right, let's just double check. 273 minus, oh, and by the way, negative, right? The biggest one's negative. Minus 245.52. 10 minus 2 is 8. Okay, 9 minus 5 is 4. 12, yeah, 27.48. Okay, so if we divide both sides by -1, we know that the average price for a baseball ticket was $27.48. Divide both sides by -1. Okay, now I can either plug that in to this equation, or we can use elimination again, and this time get rid of the b's. I'm going to plug it in because if I get rid of the b's, I'm going to have to multiply this by -2, so I'm going to have to multiply that, and this by 3, so I'd have to multiply that by 3. It'd be easier to just plug it in right here. Okay, 2 times 27.48 plus f equals 136.50. Don't forget, we already got one answer. All right, so this is, let's see, 54.96 plus f equals 136.50. So let's subtract 54.96 from both sides. Just go over to the side and do the math. It's fine. Okay. So, oh, the football's way higher. So one football ticket was $81.54, and a baseball on average $27.48. Okay, these are mixture problems. And mixture problems we get a little bit of help with. We can use a table to help us solve them. And usually we're mixing, some kind of liquid, alcohol or some kind of chemical. It doesn't have to be though. I can be mixing coffee, different price candies, or anything. But our key is if I can remember how to set up this table. Okay, percent, and this is just to remind me that I can't do math on a percent, so I change it to a decimal. And then amount and total. And it's going to be this times this equals this. So if I can fill these in, I'm going to have I'm mixing two things, so I'm going to have 2 rows, and then I'm going to have my bottom. So just fill in what you know. How many gallons of 25%, so right here, 25% goes here. 25% is 0.25 as a decimal, so I got to remember that, of alcohol, and 35% alcohol. So really, if we can just remember to write it as a decimal, we don't need that extra column. I like to have both of them just to remind me. Should be mixed to obtain. This last row is always what you're going to get in the end. So it'll say to get, to obtain, to wind up with, right? So to get 20 gallons, that's the amount, 20 gallons of 32%. So we're always trying to fill in these spaces. Okay? So, and these two things have to add together to equal this. It says how many gallons of 25%? That means I don't know how much 25%. That's our x. How many is x? But this plus this has to equal 20. When I add these two things together, it has to equal 20. Okay? So I'm going to make this, well, what if I made this 20 minus x? X plus 20 minus x is 20. Yeah, if this is 5 gallons and 20 minus 5, this has to be 15, right? To fill in our last column over here, we just do this times this. So 0.25 times x, 0.35 times 20 minus x, and 0.32 times 20. And this gives us our equation. This plus this equals that. 0.25x plus 0.35 20 minus x equals 0.32 times 20. I don't like all those decimals in there, so there's 2 decimals in every problem. I'm going to move each one over 2 places. 25x plus 35 times 20 minus x equals 32 times 20. Let's get rid of parentheses. 25x plus, what's that, 700 minus 35x equals 640. Just doing your multiplication. Combine your like terms. So negative 10x plus 700 equals 640. Okay, subtract 700 from both sides. So negative 10x equals negative 60. X equals 6. So you need 6 gallons. Now I got to go back and say of what? 6 gallons of 25% solution. And the other one is 20 minus 6, so I need 14 gallons of 35% solution. We're going to do a couple of these, but till you get the idea. But they set up exactly the same. If I can remember this little table to help me, these problems aren't too bad. Mixture problems, when you're mixing 2 things to get a different amount of something else, right? A different saturation of something else, if you will. Okay. Same thing here. Instead of alcohol, it's acid, right? But it's still, I'm mixing some pure acid with a 10% acid solution. Oh, once I realize I'm mixing 2 different strengths of something, then I'm going to make myself that chart where it's percent, decimal, amount, total. Okay, so pure acid. Ooh, if it's pure, what percent is that? Pure. Yeah, 100%. What is 100% as a decimal? 1. Okay, so I've got some pure acid, 100% acid, is going to be added to 10% acid. As a decimal, that's 0.1. To get, that's my bottom row, to get 54 liters of 20% acid. So that's 0.2. Okay. Now, if it's got to equal 54, and I don't know how much that is, what would go here to make this plus this equal 54? Yep, 54 minus that. If that's 4, this is 50. Right? If that's 20, this is 34. Okay, and once I get these spots filled in, this times this goes right here. So 1x, 0.1 times 54 minus x, and 0.2 times 54. That gives me my equation. This plus this equals that. This plus this equals that every single time if I fill in this chart. If I use the chart. I don't have to use the chart. It's just a handy way on mixture problems. Just works for mixtures. 0.1, 54 minus x equals 0.2 times 54. Once again, I don't want those decimals in there, so I'm going to move everyone over 1. Don't forget to do everyone. Now I've got a 1 right here. So if I move that decimal over one place, that's going to make that a 10. Okay, not inside parentheses, remember, not inside parentheses. It'll go there automatically. So move that decimal over one spot. All right, get rid of parentheses. $108. All right, combine like terms. And do what's being, uh-oh, I messed up. Glad I caught that. 10x minus x, 9x. Okay. So 9x equals 54. So x equals, now don't forget, I got to say how much. So x equals, I need 6 liters of pure acid. You can put 100%. Okay, so if I need 6 here, 54 minus 6 needs to be mixed with 48 liters of 10%. Don't just say you need 6 liters and 48 liters. 6 liters of which one? 48 of which one? Oh, hey, look at this one. It's still a mixture problem, but it's coffee. Like I said, it doesn't have to be those liquids. It normally is. And this one, since we don't have a percent, right, we still have the amount and the total. But maybe this one is the dollar value, kind of the strength of the coffee, the value of it. So a grocer has some $4 a pound coffee and some $8 a pound coffee that she wants to mix to make 50 pounds. That's what she's going to get in the end. That's what she wants to wind up with. That's what she wants to make is 50 pounds. And she wants it to be $5.60. Okay, so she's got some $4 coffee and some $8 coffee. If she wants 50 pounds, if that's X, what goes here? Yes, 50 minus X. And then to get our equation, we multiply. 4X, 8 times 50 minus X, and 5.6 times 50. This plus this equals this. 4x plus 8 times 50 minus x equals 5.6 times 50. So I could go through here. I see that's got a decimal, so I could go through here and make this number 40 and that 80 and that 56. But I also notice if this has a 0 on the end, instead of making my numbers giant, let's just go over and multiply that. right? Because I know that 0 is going to move that decimal to the end anyhow without making these giant numbers. Yeah, I could still make that 40 and make that 80, just like the others. Just try to think about, well, what's going to make your math easier to do? 5 times 6 is 30. 5 times 5 is 25. Plus that 3, 28. One number. So I can change this to just 280. As I rewrite it, let's go ahead and get rid of those parentheses. 4x plus 400 minus 8x equals 280. So try to think about making your math easier. Combine like terms. Minus 4x plus 400 equals 280. Let's subtract 400 from both sides. So we have negative 4x equals negative 120. Yep. Divide by negative 4. So x is 30. So she needs what? 30 pounds of $4. And she's going to mix it with 50 minus 30, 20 pounds of $8. Okay, so anytime you have a mixture problem, you can use that little table to help you come up with your equation. Okay, how about some motion problems? Anytime you're talking about, I don't care if you're talking about a train, a bicycle, a boat, an airplane, right? If you're walking, running, jogging, you've got a formula for that. Distance equals rate times time, right? We should know that formula. Distance equals rate times time. Okay, so a train travels 600 miles. So let's make this the train. Okay, the distance is 600 miles. So a train travels 600 miles in the same time that a truck travels 520 miles. Okay, so here I'm going to put my train information. Here my truck. I'm going to have two equations. A train travels 600 miles in the same time that a truck travels 520 miles. Find the speed of each vehicle if the train's average speed, so that's the rate is speed, right? So we're on the train. The train's average speed is 8 miles per hour faster than the truck's, right? So let's just call that his rate plus 8. Okay, so the rate of the train is 8 miles faster. This, we don't know what it is. We don't know how fast this guy's going, but the truck is going, we'll say R. This one's going R plus 8. Now I need the time. Notice it says the same time. So I can just put a T on both of these. I've got two variables, but that's okay because I got two equations, right? That's what the last part of this chapter was about. Now, I have got to use substitution on this one. I cannot use the elimination method. See how these are hooked together with multiplication? So I got to use substitution. I'm going to solve this bottom one for t, and then I can plug it in right there. If I divide this by r, then the truck is t equals, well, actually t is the same on both, so t is 520 over r. Let's plug it in right there. So now we have 600 equals r plus 8 times 520 over r. Anytime you have a fraction with an equal sign, get rid of the fraction. The only denominator is r, so let's multiply everything by r. Not inside parentheses, remember, not inside parentheses. So now we have 600r equals r plus 8 times 520. Let's get rid of parentheses. 600 in r equals 520r plus, let's see what that's going to be. 4160, right? If you need to, go over to the side and multiply it out. All right, put all your r's on the same side. Because it's a linear equation now, I'm just solving for that r. So 80r equals 4,160. So r is 52. Okay, now what was r? R is the truck. Remember, r was the truck. R plus 8 is the train. It says find the speed of each vehicle, so I got to say r is 52 miles per hour is the truck. And then the train is 60 miles per hour because it's 8 miles per hour faster. All right, let's try that again. Let's try that again one more time. This time we got a motor scooter and a bicycle, but basically it's the same problem. It's a motion problem, so we know that the distance equals the rate times the time. So a motor scooter travels 20 miles, that's the distance, so here's the motor scooter, travels 20 miles in the same time that a bicycle travels 8 miles. So there's my distance. Let's figure out the rate. They're going to be equals the rate. Okay, the rate of the scooter is 5 miles per hour, so it's telling me about the scooters. I don't know about the bicycles, I'm just going to use R. But the scooter is 5 miles per hour more than twice the rate of the bicycle. Twice the rate of the bicycle plus 5. This is 5 more than twice the rate of the bicycle. And once again, it says in the same time, so they both get a T because that number is the same. I don't know the rate of the bicycle, but I know the rate of the scooter is 5 miles an hour faster than twice whatever that is. Once again, I can't use elimination. I have to use substitution. So let's solve this for T. Divide by R. So notice these problems are identical, just different numbers. And now let's plug in right there. So 20 equals 2r plus 5 times 8 over r. Get rid of the fraction because we have an equal sign. The denominator is r, not inside parentheses. Okay, so 20r equals 2r plus 5 times 8. Get rid of parentheses. 20r equals 16r plus 40. All your r's on the same side. R. Okay, so 4r equals 40. R is 10. But which one was 10? Yeah, the bicycle. Yeah, this one's 2r plus 5. It's faster than the bicycle. So r is 10 miles per hour for the bike. And then 2 times 10 plus 5, so 25 miles per hour for the scooter. Okay, that finishes up chapter 7. We'll see you next time.